So microplastics are breakdown products of plastics that we use in everyday life. They're just at a size range in which you have to use a microscope in order to see them. When we get down to the nanoscale, when we're talking nanoplastics, you have to have things like an electron microscope, something very powerful to be able to visualize those particles. That's a very important point, is plastics don't disappear. So we have, 90 years legacy of using plastics, and all of them are still with us in some shape or form. When you get to the micro scale, we're looking at plastics that can then be taken up by an organism and be not just digested and then released, but taken up into the tissues of the organisms. With nanoparticles, we know that different types of nanoparticles, not necessarily plastics per se, can be taken up into the cells. What that means is that for the little critters who can consume these tiny particles, they're going to accumulate them. They have no way to get rid of them once they're taken up into their tissues. And so the next food level up, right, the fishy's gonna come along and eat the little plankton. The plankton's been exposed, fish eats them, and then we end up with it going up the food chain. The effect then is that we're probably underestimating the amount of pollution that those larger mammals and fish species are getting, because we aren't accounting for the microplastics that are an addition to the large-scale plastics, and we aren't counting the nanoscale plastics at all.
A lot of these micro and nanoplastics come from the larger items that are more obvious, but they get to a size where we can't see them. But even though we can't see them anymore, it doesn't mean they aren't having potential impacts on wildlife, on aquatic organisms that in some cases are themselves, in many cases themselves, are microscopic.
For us, it was important to also include a commercially important species, and so we've selected oysters.
The issue with microplastics and oysters is that microplastics don't biodegrade. They degrade by mechanical and UV degradation, and so they break down into smaller and smaller pieces. And as they break down into smaller and smaller pieces, many of those became the same size as the food particles that oysters would naturally eat. And there's about a $100 million industry here in the Pacific Northwest, and there's concerns that microplastics may be influencing that industry and our ability to both harvest recreational invertebrates in the future, shellfish, and as well as grow them in aquaculture. And so this is something that will influence people and our ability to conserve these natural resources.
Part of it's also going to be, we're going to try and establish some rules around what a nanoparticle does in a freshwater system versus an estuarine system versus a marine type system. So as particles float down a river, where are they going to start behaving differently and maybe settling out into the bottom of the estuary or something like that? Those are complete unknowns right now, and so we're trying to fill that large data gap.
What we do is use those numbers to say if this is much is in the beach, this is likely how much is going to be in the fish. With that much in the fish, this is how many fewer Chinook salmon you're going to have, or how many fewer shellfish you're going to have. Our job is to write the equations.
We're looking to establish a Pacific Northwest Consortium on plastics. Our research focus is going to be heavy into the micro and nanoplastics, but through the consortium we can bring together all of those regional partners that we said have been working in this area for decades now, and pull together information that they have, data that they might have, and all of this can then feed into a risk modeling framework that decision makers can then go and ask questions about, if we reduce this particular input, how is that going to look as far as the risk to the environment? People were given, ultimately at the end of our study, if they were given an understanding of this plastic is probably less harmful to the environment than this plastic, that gives power back to the people, where you then have a choice, right? And that's what people ultimately want, is to be able to have choice. And right now we just don't know enough.